Hello, I am Prasad Kanade and this is my midterm teaching video for web development course at Northeastern University taught by Professor Guerra. In this, I'm going to teach you full stack development from the browser all the way to the database. Let me start by painting the big picture. So, full stack web development has three main layers. At the top, there is front end, in which everything that runs in the browser. This includes HTML for structure, CSS for styling, JavaScript for behavior, and Bootstrap for responsive design. We also build single page applications using client side rendering. And JavaScript dynamically updates the DOM without full page reloads. And these are the main components that comprises of the front end layer. When a user does something like clicking a button or submitting a form, the JavaScript uses a fetch API to send an HTTP request. These requests use the standard methods that are get, post, put, delete. The request hits our backend, a server which is built with Node.js and the Express.js framework. Express handles routing, mapping URL paths like API users to handler functions. It also runs middleware like Express.json to parse request bodies. The route handlers talk to our database. MongoDB Atlas is the database, and we use the native MongoDB driver to perform CRUD operations, which are create, update, read, and delete. Uh, this portion. And across everything, we use tooling like ES modules for imports, ESLint for code quality, Prettier for formatting, and .env for secrets, Git for version control, and npm for packet management. This three-layer architecture, front-end, back-end, and database, is connected by HTTP requests and JSON responses. And this is the foundation of everything that we have learned from week 1 till week 7. And talking about the breadth of concepts now, I will show you what concepts we covered and how they communicate with one another. For this, I will open my VS Code and show you the code that we used. So first is this file HTML index.html in my skillsync project that I had used for a second project. So in this, let me walk you through the concept. So HTML gives our page semantic structure. For example, if we look at this HTML file, it's intentionally kept minimal because we are using client-side rendering. We have a header tag with a nav element, not a div pretending to be navigation. So this is the header tag and the nav tag, and this, as you can see, this file is pretty small. There's a very less amount of code as I was talking earlier. We have a header tag, that is this one, and we have a main tag as well with id equals to app, this one, where JavaScript renders content, and we have a footer section as well. The script tag has module equals to type equals to module, and this enables ES module imports in the browser. And if we link the 5 CSS files together, then this becomes one per component. And as we saw earlier, CSS controls styling. There are three main components when we talk about CSS files. Let me show you a CSS file. This is the one, main.css. So in this, the first is the box model. Every HTML element is a box with content, padding, browser, and margin. We use box sizing, border box, so padding and border are included in the element's widths. This makes the layout predictable. Second is specificity. When multiple CSS rules target the same element, the browser resolves conflicts using specificity. ID selectors beat class selectors, which beat element selectors. And we avoid using exclamation import. So, this is the specificity I was mentioning earlier. These lines of code, as we can see here. And the last one is CSS modules. We organize style sheets by component. For example, if we look at the CSS file structure, all the files that are present here, the main.css has global styles, which includes the reset, body, buttons, cards, and form groups. The profile.css, this handles the profile page. Next is availability. This handles the time grid, as in which user is available at what time. Next is projects.css. This handles the various project cards that are available. Next is requests.css. This handles the page, requests page and browse page. Each component get its own file. This keeps the CSS maintainable as the project grows substantially. uh, Post this, we have Bootstrap. So, Bootstrap provides a responsive grid system and pre built components. It uses 12 column layout with breakpoints such as extra small, small medium, medium, large, or Excel, so that your page adapts to different screen sizes automatically. And we learned in it in week 3 alongside JavaScript. Now moving to JavaScript component, let me show you its code file, that is api.js, that is present in this particular folder structure. So JavaScript is the language that powers both frontend as well as backend. Firstly, closures. So closure is a function or a component that remembers variables from its outer scope even after that scope has finished executing. This is how callbacks and event handlers work in JavaScript. Next is ES modules. We use import and export and we don't use require. This file imports functions like get users, create users, and get projects. Other file imports only what is actually needed. The type module in this, let me show you type module. Uh, Type module is in package.json. I apologize. So yeah, this line. So the type module in package.json enables this on the server side. Next is DOM manipulation. So in this project, every page is rendered by JavaScript setting inner HTML on the app container. So when you press the profile in the navigation bar, JavaScript renders the profile form, no page reload. This is client-side rendering. And the next and the most important part is Fetch API. Fetch sends HTTP request to our backend. For example, the various requests that we saw earlier, that is uh, push, post, delete, all these are the various requests that we can make. So when a request is made, it returns a promise, as in we use async wait to handle it correctly. This is the async wait function I'm talking about. The response comes back as JSON, which we parse and use it to update the DOM. Post that, we'll be moving to Node.js, and for this, I'll be opening package.json file. So Node.js lets us run JavaScript on the server and outside the browser. NPM is the package manager. Package.json lists dependencies, Express, MongoDB, .env, and scripts to run the application. NPM starts the production server. npm run dev uses watch for auto reload during development. The type module, this particular line, helps Node to use ES module syntax. This is required because the course prohibits us from using common JS require. Talking about Express now, which integrates the front end as well as back end, let me open its necessary file, that is index.javascript. So Express in our web framework, it mainly does three key things. First is, let me show express.static. Yep, this particular line on line 15. So static file serving. This one line serves our entire front end, all HTML, CSS, JavaScript files from the public folder. Next is express.json, this particular line. So this is the middleware. Express.json parses incoming request bodies, so route handlers can access request.body as a JavaScript object. And next is app.use, the function that actually calls this inner bodies. So this is the routing component. Each URL path mounts a separate router module. App.users go to the users router, app.availability goes to the availability, and so on. And let me show you the Express architecture now. Yep, this is it. So the main server file mounts four routers. Each router handles CRUD for one of the MongoDB collections. As we can see, this is the main component and these are the various requests that can be made. And they all share a single database connection through the connection module. And talking about database, we'll now be moving to our database component, which is MongoDB, and this is its file connection.js. So MongoDB is our NoSQL database hosted on Atlas, the cloud. We connect using the native MongoDB driver and not Mongoose. Mongo client takes our connection URL from the .env file and we create one connection at startup and share it via getDB. So this is the connection that we set up here initially itself, and then if it fails then we give the necessary errors. So data is stored as documents which look like JSON objects inside collections. Unlike SQL databases with rigid tables, MongoDB documents can have nested objects and arrays. Our user collection has a skills array and a work style object. Let me show you the live API that I have created now. Users, yes, so this is the live API, and in this each document has an ID that is generated by MongoDB plus the fields whatever we want to define. For example, there's name, there's email, there's skills and work defined. So this is all of the individual component that we can create. Moving on to the next part, we'll be talking about tooling now. While talking about tooling, there are various files that are responsible for it. For example, there's Prettier, in which we basically format the code consistently. There's ESLint, this file. So this catches all the errors that can happen before runtime. And we also have a .env that keeps our database and passwords. Yep, this file. So this keeps all our passwords out of our code. And we have a git ignore file. So this prevents node modules and other env components from being committed. And we deploy to render which auto builds from GitHub. So let me show you the actual website that we had deployed. So as we can see here, it is deployed on render and it is a perfectly working website. Finally, the tooling is the component that ties everything together. Prettier formats code consistently, ELS lint catches everything before any errors can occur. And now we have covered the breadth of all the things that we learned during the past 7 weeks. And now I will be explaining a particular topic in depth. Let me show you the a diagram through which I can explain you guys better. That is the CRUD operations table. Yes. So I want to go deep on one concept that ties the backend together. That is building a REST API with Express and the native MongoDB driver. So REST stands for representational state transfer. And the key idea is simple. URLs identify resources like API slash users or API slash projects. HTTP methods identify actions on those resources. So if we look at each row, that is get ID, post, put, delete. So get reads data, post creates data, put updates data, delete removes data. The same URL, that is API slash users slash ID, does completely different things depending on which HTTP method that you want to use. And each method maps directly to a MongoDB operation. Get uses find or find one, post uses insert one, put uses update one with a set value as well, and delete uses delete one. And to demonstrate the entire life cycle, let me show you another diagram. Yep. So let me trace the full life cycle of a request. So when a user creates a profile in the skill sync, here's exactly what happens. The user fills out the form and clicks create profile. The JavaScript calls fetch with method post, sending the form data as a JSON string in the body. The request hits Express. The Express.json middleware parses the JSON body into a JavaScript object as a request.body. Express matches the URL slash API slash users with method post to the router handler, that is router that post slash. The handler calls db.collection users insert one with the new user insert data. MongoDB creates a document and returns the generated ID. The handler sends the JSON response with a status 201 containing a new user object including the ID. Oh, we are here. And back in the browser, JavaScript receives the response, stores the user ID in local storage, and updates the DOM to show the logged in state. Each interaction in the app follows the exact same cycle. Read a user, create a project, send a request, and same pattern. Now let me walk you through the actual code in which users.js. So looking at the imports, we import Express object ID from MongoDB and get DB from our connection module. These are ES module imports. We create a router with express.router. Next is get. The get handler for the root path reads all users. Get DB returns our shared database instance. db.collection users selects the collection. Find with empty object means no filter and get everything. And request.json sends it back with a HTTP response. this component entirely. Now talking about get.id. So request.params.id. So this is used when we want to extract the ID from the URL. The new object ID converts the string to MongoDB's binary ID type. Find one returns a single document or null, and we check for null and return 404 if it is not found. The post creates a new user. Request.body contains the parsed JSON, that is name, email, skills, and we construct the document and call insert1. Result.inserted1 inserted ID gives us the auto-generated ID, and we return status 201 if the HTTP code is created. Next is put ID. So put updates an existing user. Update 1 takes two arguments. First is a filter, which document to update, and the second is an update, that is $set, replaces only the specified fields without touching anything else. Next is delete. So delete removes a user. Delete 1 finds and removes the matching document. Delete count tells us if anything has actually been deleted. So that is the functionality of delete. And next is try catch block, so which we can see here. This is the try and this is the catch component. So if MongoDB throws an error, that is bad ID format, connection timeout, or any of such errors, then it can be handled in the catch block with a return 500 status. As we can see here, the necessary errors are given for everything, and without this the server would crash. Finally, we export the router as the default export. Back in index.js, we import it and mount it on API/users, and the same pattern is repeated everywhere for every collection. So once you understand one route, you will understand rest of the 4 routes. And let me show you the live API endpoints as well. As we can see here, the health of the application is alright, it is up and running. Next is the various users for which the APIs are up and running. Same for projects as well. Now let me show you the working component in which I will do live coding and help you understand how do we actually build it from scratch. For this, I will open my VS Code and move to this particular section, and I have created this file called as server.js, in which I will be giving you the demonstration. So let me build a REST API from scratch to help you understand how quickly it is to build this pattern and how you can work on it further. And I have already installed the necessary npm and Express MongoDB and .env, so that less time is given for this, and we can directly start working on the server component. This is the JSON file. This is the JSON file in which we have mentioned all the Node and Mongo and all other components necessary. This is the env file which mentions of our MongoDB connection. Yep. So let me start with it. To begin with, now we'll be writing all the import statements, that is import express from express, import I want Mongo client, I want object ID as well, and we'll be getting this from MongoDB. Next is import dot env from dot env. So I'm setting up all the imports here for now. Next is .env.config. I will just write all the code once, and then I will help you understand what is the purpose of each line. Constant tab equals to express. Let me just quickly check what errors I'm getting. Object is defined. All right. We'll skip these errors for now. Next is the async wait, in which I want async function start, in which I'll be giving await client.db. Connected to DB. So if we make a successful connection, then we'll be giving this message. Next is get all tasks. So this is the purpose of the code I'll be writing now. Next is app.get. I'll be sending two parameters here. One is request, next is response, and I will be putting it in const of tasks equals to await db dot collection of tasks. Find URL to array. Let me just quickly check if this is all right or I am making any mistake. JSON passing tasks. post, and this is const task. Res.status will be giving 201 as a success message, and JSON F. Yep, so as we can see here, this is what the final file will look like, as in we get all the necessary tasks that are present here. That is the get API request. Next is the post. Yeah, next is post, and then there's the delete task, in which if all the tasks are done successfully, all the necessary methods are created successfully, then we should be able to see our application live and running at the local host 3000. And let's test it with our command, that is node server.js. So yep, so as we made a successful connection to our MongoDB Atlas, because of which it is connected now, and our application is live and running at localhost 3000. As we can see here, it is an empty array currently, and if we move to this particular browser, that is task, then we can see all the tasks that were created earlier. So now we'll be creating a new task, will be making a new request, which will be having the timestamp of current time. So let us make that request as well from the uh, terminal. So I have created this line which will initiate or trigger a request, and once it is done successfully, then we should be able to see a new item that is added in this tasks on the browser. So let me press the submit button, and yep, we can see that it has been created. Let us quickly verify it at the browser. Let me do pretty print, and yes, our newly added request is now created here and it is seen here. So the document is created with underscore id and name and created at item. So that's a working REST API request that we created, and the code is not at all big as well. It is hardly about 40 to 50 lines which are developed in front of you. And the pattern is always like this: connect to MongoDB, define routes with HTTP methods, use the native driver in CRUD, and return to JSON. This is exactly what we scale up in full projects. Now, to wrap up the entire presentation or the entire video, let me show you my actual working project, that is SkillSync. So throughout this video, I have used my own project SkillSync as a real world case study. Every concept that I explained for the past 30 minutes has been covered in this deployed application. The connect map I showed you, it is not abstract. It's literally the architecture of this application. The HTTP provides the shell, the CSS styles each component, the JavaScript renders the pages and calls the API. These are the various components that we built using HTML, CSS, JavaScript, Node backend, and Express. So that's the full stack web application that I have created, and I have incorporated every concept or skill that I have learned from week 1 till week 7. My name is Prasad Kanade, and this was my video. Thank you so much for watching.